Alright, there's a video for 3VT about exercise 61 and also exercise 62 later on. This is about solar panels that are placed on a roof. They're always placed in that position so they absorb a lot of sunlight. Also, there's a bit of space here between two solar panels because otherwise this one would be in the shadow of the other one and that wouldn't be very efficient. It says here the solar panels are placed on a flat roof and the length AP is 180 centimeters. That's the length of a solar panel. And the angle of elevation is 9.6 degrees. So it's a bit hard to see in the picture, but here we can also see how big the angle is. It's 9.6 degrees. The distance between the solar panels A and B, that's the distance there, is chosen so that this one does not cast a shadow on the other one. I think I already said that, right? That means that this angle here is 15 degrees, that's what they say here, because that's in the end of December the sun is so low that it will be in that position. Now we need to calculate the distance from A to B. So here's how we have to do that. First we need to calculate what this length is from P straight down, because then we can use that length to calculate both this length and that length, right? And then we know the distance from A to B. So I'm going to write down the answer like above it a little bit. First I want to calculate that length. So I'm going to use this angle, that's 9.6. I'm going to use the hypotenuse and I want to know the opposite side. That means that I have to use the sine. So the sine of 9.6 is equal to the length that we don't know divided by 180. So if I want to know that length that we don't know, you have to do 180 times the sine of 9.6. Now if you calculate that, you get 30.01. So that's this length over there. Now because this is a rounded off number, I'm still going to use the 180 to calculate what that length is, because then it's a bit more exact. If you want to calculate this length, then now we have to use the cosine, because we want to know the adjacent side and we already know the hypotenuse. So the cosine of 9.6 is the question mark divided by 180. So if you want to calculate the question mark, you have to do 180 times the cosine of 9.6. And there you get 177.47. And then it has a few other decimal places. So that's this length. Then if you want to calculate what that length is, right? Then here we have the 15 degrees. We know what this length is. So we have to use the tangent because we're going to use the opposite side and we want to know the adjacent side. So I'm going to write down the tangent of 15 is 30.01 divided by what we don't know. So you have to do 30.01 divided by the tangent of 15. Now if you calculate that, you get 112.03. Now then we're going to calculate what AB is now. So AB equals, I'm going to round it off to a whole number. If you add this, you get 289.5. So round it off, that's 290 centimeters. So that's the whole space it takes to put the solar panel there. Okay. Then for question B, it says that the solar panel is 80 centimeters wide. So that's the depth in the picture, like the depth that goes inwards is 80 centimeters. What is the maximum number of solar panels that can be placed on a roof of 18.5 by 6 meters? Alright, so the roof is 18.5 by 6, so you can either put them like this or you can rotate them 90 degrees. Alright, so what we need to do is look at both positions and see when the most solar panels will actually fit. If you the solar panel is, well, this length is 290, right, and the depth is 80. So let's say that we put the longest side also in the longest side of the roof. So we're going to see how many times does 2.9 meters fit in 18.5 meters, and then also how many times does 80 centimeters fit in 6, right? So let me see. I think I have it earlier worked out here. This is 6.4, so you can place 6 of these solar panels then next to each other, and this is 7.5, so that would be 7. So if you do 6 times 7, that means you can place 42 solar panels in total. We can also orient the if you rotate it 90 degrees, that means that in the 18.5 meters we actually put the short side of the solar panel, so like the width, and then here we put the bigger side, like the 2.90, right? Well, here you get, or rounded off, you get 2, right? So it's going to fit in there 2 times, and if you take a look at the other one, if you round that off, it's going to fit in there 23 times. So 2 times 23 is 46. Yeah, so this would be better actually. So that's the answer then, 46. Now one thing that because this is also what the answer book does there. See, it says here 46. That's it. One thing that the question is not taking into account is that the final solar panel that you place doesn't have to use this length, right? Because that's going to be at the edge of the building anyway. So, but I don't think that will change the answer. So we'll just leave it at this. So this is the answer for exercise 61. Kind of a big exercise, as you can see. I've been talking about it for almost 6 minutes. But now we're going to take a look at another exercise. This is Barbara, and she's looking at the CN tower from her hotel. Here's her hotel, and this is the CN tower. She's looking at that. And the hotel room is 24.5 meters high, so that's where she is located. The CN tower is one of the tallest buildings in the world. She sees the part of the tower above the panorama platform. So this is the panorama platform, so she sees this part at an angle of 14.5 degrees. Now we need to calculate the height of that panorama platform. And we also need to calculate the total height of the CN tower. Well, the first thing that you should look at is 90-degree angles, because a triangle needs to have that, otherwise you can't do anything. So I see a 90-degree angle here, which is kind of useless. But if you make a line from where Barbara is standing, and then we're going to make the line all the way over here, then we have another 90-degree angle there, and that's going to be very useful, because now I have a triangle here that has a 90-degree angle, and I have a triangle there that has a 90-degree angle. The only problem is that the 37.5 is no longer accurate, because the 37.5 is this whole angle, but I want to know what is this angle then. Alright, so to calculate that, we actually need to calculate what this angle is over here. So like here you have 24.5 and then you have 470, because if you know what this angle is, then you also know what that angle is, because those are the same. This is a Z angle. Right, so that means that this one's the same as that one. And then if you subtract that from 37.5, you know what that angle is, and then we can do the next thing. So first we're going to calculate this tiny angle there, right? So let me just write it down over here. We're going to use tangent to calculate the angle, and then 24.5 divided by 470, and then that is, and then we see what that is. That's